Okay, really quick lesson. If we have a function, we'll call that function f of x, and we have some x values, let's call them a, b, and c. Then the integral of f of x dx evaluated from a to b represents the area between that function and the x-axis between those two x values a and b. If you have an integral from b to c of that function, then that integral represents the area between the function and the x-axis between the x values b and c. And I think that you would agree with the argument that if we had an integral from a to c of this function, then that integral would have the same value as our first integral from a to b plus the second integral from b to c. In other words, the area beneath the curve from a to c is equal to the area beneath the curve from a to b plus the area from b to c. So that's a pretty good rule for integrals. We're going to use that in this problem. Another rule that we're going to use is that if you take the limits of an integral and switch them, instead of going from a to b, we integrate from b to a. That just gives us the negative result of the original integral. All right, keeping those rules in mind, let's try to do some problems. This first problem might be a little bit easier if we take that constant of 4 and bring it outside of the integral. And maybe I'll draw a little picture to represent what we're going to do with the rest of this problem. What we're ultimately trying to find is the area underneath this function between the x values of 3 and 4. However, what we're given in this problem is an area beneath this function between x equals 3 and x equals 8. That would look something like this. The area enclosed in the pink area would be 13. And you'll also notice that for the function f of x, we're given that this area between the x values of 4 and 8, that would be this area down here, that area adds up to 5. So what we can conclude from this picture is that this little blue area that I drew originally should be the pink area minus the orange area. That would be 13 minus 5, which adds up to an area of 8. That area is this integral evaluated from 3 to 4 of the given function. So to get our final answer, we would multiply 8 by 4 to get 32. If we wanted to show this concept a little bit more mathematically, what we could do is keep this 4 outside of this integral and say that the integral evaluated from 3 to 4 is equal to the integral evaluated from 3 to 8 minus the integral evaluated from 4 to 8. Simplifying then gives you 13 for this integral. We were given that the value of this integral was 5, and you can see that simplifying we will again get the answer of 32. Now that we understand some of these concepts, hopefully these problems will get a little bit shorter. As far as the second problem goes, because these two functions are subtracted, we can split this integral into two pieces. We were given that the value of this first piece is 13. We're given that the value of this second piece is 7, so our answer for part B should be 6. For the third problem, we can split up this integral the same way as before. For the integral of f of x from 3 to 4, we can recall from the first part of this problem that we found that the area underneath this function f of x between x equals 3 and x equals 4 added up to 8. Then we can look at our list of given information to see that this second integral was given to us as 3, so the answer to this problem is going to be 5. Let's keep moving. We can again split this integral into two pieces. Our first piece asks us for the integral evaluated from x equals 4 to x equals 8 of our function g of x. To get this value, we need to combine the information that we're given here and here. Notice that this first integral tells us that the area underneath this curve between x equals 3 and 8 is 7, and the second integral tells us that the area under this curve between x equals 3 and x equals 4 is 3. But what we want is the area underneath this curve between x equals 4 and x equals 8. To get that, what we can do is subtract the 7 minus the 3. That gives us a value of 4. And then for this integral, I believe it's given up here in the problem as 5. So our answer to this part of the problem is going to be -1. We have two more parts to this problem, so let's see if we can get those finished quickly. For part E, we want the integral from x equals 4 to x equals 8 of 9 times g of x. Well, recall that we can bring that 9 outside of the integral. And then I believe it was just the previous part of this problem where we determined that the integral of g of x from 4 to 8 has a value of 4. So what we can do is we can just take that 9 that was outside the integral, multiply it by the 4 that we got in the previous part of the problem, and we get an answer of 36. Finally, we want the integral evaluated from 4 to 3 of 3 times f of x. Now we can recall that somewhere earlier in this problem we had an integral evaluated from 3 to 4 of f of x dx, and we found that that was 8. Well, what that tells us is that if we want an integral evaluated from 4 to 3 of the same function, we're just going to put a negative sign on that and we're going to get a value of -8. So back to the original problem, we can pull this 3 out of this integral. We just discovered that the value of this integral that remains is -8, so we're going to multiply that by 3, and we're going to get a final answer for this part of the problem of -24. And okay, that was a lot of work. I'm going to zoom out on this thing so you can see all of the steps that we did. I hope that this helps you out in your your understanding of integrals and areas. We're going to be evaluating some integrals in the next video, so I will see you there.